Alright, hi everybody. It is Friday, and today we're doing our kind of third section, I guess, of our R5 to R7 unit. We're going to be talking about complex fractions. What you need to know about complex fractions and what they are is that it is a fraction or a bunch of fractions on top of another fraction. Whoops, if I could spell fraction. It's Friday. Okay, fraction. And what you're going to be doing is simplifying fractions individually. You're going to simplify the top, simplify the bottom, and then we already talked about a while ago how to divide fractions. And so that's what we're going to be doing today. So, sorry for my absence today. I'm out of town and I've had this plan for a long time, and I didn't want you guys to be completely out of the loop when you had to do your homework. So I want to give you a few examples to go by on how I want you to do these problems. So, just a couple examples here. First of all, complex fractions. You're going to simplify the numerator and the denominator separately. Okay, so you're going to look at it basically as like two different problems. The numerator is going to be problem number one. You're going to combine fractions, which means you need an LCD and you need to multiply and simplify and all the other stuff that we've been doing when you add and subtract fractions. And then you're going to do the denominator separately. So then you're going to have a fraction on top of a fraction, which means a fraction divided by a fraction. And you do know how to divide fractions. You take the numerator and you multiply by the reciprocal, or flip the denominator. Okay, so just remember, all you're doing is dividing fractions, but it takes a lot of simplification before you can start this. So an example would be, and we've done it, this is a brief example, but if you have x plus 2, you don't have to copy this down, but just watch. If you have x plus 2 over x and you're dividing by x plus 3 over x, you know how to divide fractions, right? You flip the denominator, or if they're written in standard form, written out, you flip the second one, is what we've been doing in class. So what this ends up being is x plus 2 over x times, flip the denominator, so x over x plus 3. That makes sense so far? And then you just cancel out the x's, and you're left with x plus 2 over x plus 3, and there's your final answer. So that was a really basic example, but that's what all these are going to look like. They're fractions on top of fractions. You just have to remember how to divide fractions. You flip and multiply. Okay? All right, let's tackle our first example. You ready for this? It's going to be crazy. You're going to be dealing with a lot of negative exponents when you do these kinds of problems. Okay, so what I'm going to do is I'm going to first move this problem so I have more room to write. Okay. I'm just going to do the top first. I'm just dealing with the top, so literally cover up the denominator and forget about it for a second, because we are just going to simplify the top into one solid fraction. You know a to the negative first means 1 over a, plus, you know b to the negative 1 is 1 over b. Again, we are just dealing with the top of the fraction right now. And if I wanted to add these two fractions together, they would have to have a common denominator, right? So they would need an a and a b in the denominator. Which means, and we've done this before, we've added fractions with unlike denominators, so that's kind of where we're bringing back section R.5 a little bit. So I'm going to multiply top and bottom of the first fraction by b, and I'm going to multiply top and bottom of the second fraction by a, so that they have the same exact denominator. So that denominator stays, and it is ab, and the top is just b plus a. Okay? If we were only dealing with the numerator, then this would be our final simplified answer. But we are also dealing with the denominator, so I'm going to do that one down here. So problem number 2 is to simplify just the denominator. And all I'm going to do there, again, it's a negative exponent, which means it is 1 over the quantity AB. Okay? So if you look at what we have now, we have a fraction divided by another fraction. So we simplified the top into one fraction, we simplified the bottom into one fraction. Now all we have to do is flip and multiply, and then we're there. Okay, so the top is the b plus a over ab, and we're going to flip the bottom and multiply. It ends up being ab over 1, and you can see what's going to cancel. The a's cancel, the b's cancel, and we are left with our final answer of b plus a over 1. Which you know is just b plus a. Okay, how do you like that? It's kind of crazy, and it actually is a lot of work. So each of these complex fractions are kind of like two problems in one, where you have to simplify the top, simplify the bottom, then flip and multiply. Alright, let's try another one. Give you a second to get it copied down. I'm going to move this up to the top a little bit so I have some more room to work. So the quantity x plus y to the negative 1 over x to the negative 1 plus y to the negative 1. So this problem is going to be kind of similar to the first one that we did. Again, we're just going to deal with the top first. That negative 1 exponents means I'm going to make it into 1 over x plus y. That's just one solid fraction, no negative exponents. We're done with simplifying just the top. And the bottom we're going to do the same way that we did the earlier one. X to the negative 1 means 1 over x plus y to the negative 1 means 1 over y. I'm going to keep my divisor bar in there. And again, we need a common denominator. Common denominator is going to be both x and y. The first fraction needs a y top and bottom. Second fraction needs an x top and bottom. So when I add those two fractions now, they have the same denominator of xy, and the top is just y plus x. Or you know it's the same thing as x plus y. Okay, so from here now I have one single fraction on the top, one single fraction on the bottom. Now I need to flip and multiply. So the top is still just 1 over x plus y times, I need to do the reciprocal of the denominator. So the xy is going to be on top, and the y plus x on the bottom. And you know x plus y and y plus x are the same thing. So when you multiply now, we have 1 times x plus y, which is just, or xy, which is just xy. And the bottom, we now have 2 of the quantities, x plus y, on the bottom. So I'm just going to write it as x plus y squared. Remember, even though because they're backwards, because it's an addition problem, it means the same thing. There was nothing that canceled in this one, and you guys should get used to that too. Not always will you have a bunch of stuff cancel and simplify. And this is one of those examples where nothing canceled. Okay? All right. Let's try another one. So now we have some binomials in the denominators. So it just kind of makes these problems a little bit more writing in order to find the LCD. Let me move this guy up a little bit. Again, we're just going to start with the top. So you know that the whole number 1 is just 1 over 1. I'm just going to write this out a little bit more room. So the denominator should be x minus 1. So that means that the 1 over 1 needs x minus 1 top and bottom. Okay, so my numerator, first of all, now they have the same denominator, so that denominator stays. But the numerator is just going to be, if you distribute the 1, it doesn't do anything. So x minus 1 and then plus 1, because of this plus 1 right here. And the 1's cancel on the top, which is good. X minus 1 plus 1 is just x. And the denominator stays x minus 1. Okay? There is the simplified numerator. So now we're going to do the same thing with the denominator. Again, it's still 1 over 1 minus 1 over x plus 1. So this is very similar. Again, we need our denominator to be x plus 1. So we got x plus 1 top and bottom. Which means I distribute my 1, which again doesn't do anything. So I have x plus 1 and then minus 1. And the denominator is just x plus 1. So again, the 1's cancel here, which is nice. So we have x plus 1 minus 1, which is just x. And x plus 1 on the bottom. Alright, and here we go again. We have a top fraction and we have a bottom fraction. So in order to divide fractions, we flip and multiply. So you got x over x minus 1 times, we're going to flip that denominator. So x plus 1 ends up on top and x on the bottom. And you can easily see that these x's are going to cancel. And our final answer is x plus 1 over x minus 1. Woohoo! Okay, what are you guys thinking? It's pretty methodical. And again, it's one of those, the homework section from a few days ago was kind of rough. It was the adding and subtracting, finding the LCDs. That was when I gave you all the even answers that you should have checked. And again, those odd problems on page 50 are there if you're still really struggling with your LCDs and adding and subtracting and getting common denominators. Those would be good problems to try because all the odd answers are in the back of the book. Okay, let's try this one. We just got 2 left, so this one and one more. Alright, there's not much to do for the numerator on this one. The entire quantity has a -1 exponent, which means it's just going to be 1 over the quantity, a minus b. Okay, so that was easy. That was the top of the fraction. Now let's get working on the denominator here. Keep my little bar. Alright, a to the -2. Again, we're going to make that 1 over a to the +2. Keep the minus sign in the middle. And b to the -2 just means 1 over b squared. And then we're going to have to do our common denominator business with the denominator here. So the denominator should be a squared b squared, which means this guy needs b squared top and bottom, and this guy needs a squared top and bottom. Okay, which means that my denominator is going to be a squared b squared, the combo, and the numerator is b squared minus a squared. Okay, I have one single solid fraction for the top and one single solid fraction for the bottom. Now I'm going to flip and multiply. Some of you are noticing, hey, this is a difference of squares, it factors, and you are absolutely right. Raise your hand if you notice that. Raise it really high. Some of you have no idea what I'm talking about. Okay, that's all right, we'll get to it in just a second. Okay, we're going to flip and multiply. So I'm going to take the numerator, which is 1 over a minus b. I'm really excited for you if you recognize that difference of squares. Sorry for my excitement. We're going to flip and multiply, so we got a squared b squared on top and b squared minus a squared on the bottom. And yes, difference of squares. Okay, let's factor it. So the top is just going to be a squared b squared. This factors into b minus a, b plus a, right? So I'm going to cross that out because that's what it factors into. It is a difference of squares after all. And keep in mind, these two factors are not the same, so it would not be correct to write a minus b, the quantity squared, as your common denominator here. They are two different factors, so unfortunately you need to write all three. A minus b, b minus a, b plus a. And nothing cancels in this example either, so it is long and it is ugly. It's not ugly, actually, it's beautiful, all that work that we did. But that is your final answer. Nothing cancels. Yeah. All right. We've just got one more. We're going to go out with a bang, and then it is Friday, and then you just get to work on your homework. All right, last example. Here it is. It's going to be somewhat of a doozy. 5 over x squared minus 4 plus just x. The denominator is 1 over x plus 2. Hey, what's good about this denominator, while you're copying it down, is that it's already one single solid fraction. There's nothing that can be simplified or reduced for just the denominator, so we only have to combine the two numbers on the top here. Okay? So, here we go. I'm going to write 5 over x squared minus 4 plus x over 1. Okay. Yes, x squared minus 4 is a difference of squares. You could factor it or you could leave it for right now because we'll end up factoring it at the end. So, just as an FYI, yes, we have another difference of squares here. And I'm going to need that to be my common denominator, so I'm going to multiply x squared minus 4, top and bottom. If you factored it out into x minus 2 and x plus 2, that's fine. You can do that. It's a little bit more writing, but it's not a big deal. Okay, so now my denominator is x squared minus 4, and the top is something really ugly, so it's 5 plus, and now we have to distribute this x, so we get x to the third minus 4x. That is something really ugly and really strange, but that's the top. We're not going to discriminate. And then we have all the stuff on the bottom. So here's my numerator, here's my denominator. Now let's flip and multiply. I'm going to rewrite this so it's in descending order, the numerator up here. I'm going to write it as x to the third minus 4x, and it's a positive 5, so plus 5, over x squared minus 4 times, and we got to flip the denominator. And again, the denominator didn't need any work, so that was good. X plus 2 over 1. Now you can see that something's going to cancel because of our difference of squares down here. I'm going to cross out the x squared minus 4 and actually write it as a difference of squares. Now you can see what's going to cancel. We have our binomial x plus 2 up here, and our binomial x plus 2 down there. So our final answer is that ugly trinomial on the top, x to the third minus 4x plus 5. And the only thing left in the denominator besides the 1 is the x minus 2. And that is it. Okay. So they are a little bit of longer problems. There's not as many as you're used to in the homework, but hopefully you'll have a good chunk of time in class to work on them and work on them together. And check your answers, of course. And other than that, I hope you guys have a great weekend, and I'm going to see you on Monday.